In this exercise, we need to determine the kernel of a linear operator of R3. The linear operator is given like this. Recall that a linear operator is just a linear map where it's mapped from R3 to itself. Right. The domain and the codomain are the same, so we call it operator. And this is a linear map. And recall that the kernel of F is a set of points in the domain, say x1, x2, x3 in the domain. Domain is R3 such that these points map to 0 in the codomain. F of x1, x2, x3 equal to 0, 0, 0. And this 0 is a 0 vectors in R3 in the codomain. Okay, so this, and they are all the same because we have a linear operator. Okay, actually the same things, we do the same thing for linear map. So the set of points in the domain such that is mapped to the 0, the point 0 vector in the codomain. Wherever this is R3 or R2, any other vector space can be defined like that. Kernel is a set of point V in the domain which map to vector 0 in the codomain. And by definition, okay, we still have this x1, x2, x3 such as that. So use the definition of F. We have x1, F of x1, x2, x3 is x1, x2, 0, right, equal to 0, 0, 0. And what is this? This gives us x1, x2 are 0, right? x1, x2, x3 in R3 where x1 equal to x2 equal to 0 and x3 can be chosen arbitrarily. And this gives us the kernel is the set of points of the form 0, 0, x3. So x3 is just arbitrary real number, and therefore the kernel is just one-dimensional vector space, right? It's a subspace of R3 contain all the points. So you can write one more step. It's span of E3, right? 0, 0, 1. It's just one-dimensional vector subspace of R3 which expanded by this E3 vector 0, 0, 1. Right, so the kernel is one-dimensional vector subspace of R3. Vector subspace. That's spanned by say vector E3. E3 we use a notation in the standards basic of R3, right? E1, E2, E3. Okay, so this is the way we find the kernel of a linear map.